All right, we talked about what the column space means and what the null space means. Let's go back to the original matrix and let's actually talk about crunching some numbers here. So let's take this example in two parts. Just describe the column space and describe the null space. And when we say describe in this course, or at least for this problem, let's take that to mean like give a formula for. It's pretty easy to describe the column space. It's pretty much in the definition, which is a way to describe or give a formula for the column space is just any constant times 2 negative 3 plus any other constant times 6 2 plus any other constant times 4 5. That's a description for the column space. You pick your A, B, and C and plug them in, and you've got a member of the column space. If you're thinking ahead a little bit, you might realize there's a more efficient way to describe the column space. These are R2 vectors. They're linearly independent, at least the first two are. So we could use something like 1 0 0 1. I mean, the column space here is all of R2, but that's for section 4.3. Right now, all we need is any description of the column space, and this is it. There's a formula for generating any and all elements of the column space. The null space takes a little bit more work. I want to know every vector that I can multiply by A and get 0 as a result. So I'm basically solving AX equals 0. And again, probably our most efficient way to do that is good old-fashioned augmented matrix and row reduce. All the way back to chapter 1. So row reducing that guy, and again, you should be able to do this by hand, but 2 and negative 3 aren't my favorite numbers, so you should be able to use a calculator on this as well. Totally fine. Right? Row reducing by hand is not the point in this section. So we get this as our row reduced matrix. So let's go ahead and copy that over. 1 0 0 1. I already forgot. It's negative 1 1. And 0 0. Okay, that's the row reduced matrix, but we're still looking for our A, B, and C, or x1, x2, x3, or whatever you want to call them. I'm a little more comfortable with x's, so let's go translate these back into equations and say this is x1 minus x3 equals 0. This is x2 plus x3 equals 0, and of course for an actual solution set here we like to see them solved. So x1 equals x3, x2, I did that thing again. It's not 3x, that is x sub 3. X2 is negative x3, and of course x3 is a free variable, so I tend to write it x3 equals x3. So my solution set here looks like, in vector form, looks like 1, negative 1, 1 times x3. So any multiple of 1, negative 1, 1 is a member of the null space. I think in the previous video when I gave you an example for the null space, I gave you 1, negative 1, 1. But it turns out that 2, negative 2, 2, or 5, negative 5, 5 would have worked as well. Or x3 could be 0, so 0, 0, 0 also works as a member of the null space. So there's a couple homework problems that ask you to just explicitly, they don't bother with the column space, but they ask you to explicitly describe the null space. And again, that's just going back to augmented homogeneous matrix, reduce, and write the answer in vector form. And we do know, by the way, this is the span of a vector set of vectors from R3, just a single vector from R3, which automatically makes it a vector space. Okay, in the next video, we'll knock out a couple examples from the homework, and then you'll be good to go.